Hello, everyone. Today we're going to talk about another data structure, and this is also a very common data structure, and this is called linked list. So from the name, you can understand that this is some kind of list that contains, that stores data, and any data structure is actually used to store and organize data. And linked list is a linear data structure. So it's a linear data structure. And it's unlike array, this is dynamic in size. By dynamic in size means when we declare an array, we specify its size or length of the array, but in linked list, we don't need to do that. So this is how a linked list looks like. So you can think every is a list of data or objects. So every node has some data in it. So suppose some data in it, and it is linked to the next chunk of data. Okay, so suppose I want to store, say 3, 5, 10, 1. These data I want to list, create a linked list out of it. So what I do is initially I create something with value, like an object with value 3, and then next time when 5 comes, I create a link and create another node. Next time when another value comes, I add it to the previous node. So I keep on adding these or acquiring memories from computer whenever a new data comes. So basically, that's why it's dynamic in size. That means depending on how many, how much, depending on the amount of data or how many data I need to put into the list, I keep on adding to the linked list. So this is roughly how a linked list looks like. And as you can see, unlike array, linked lists don't have index. So we don't have that random access advantage that we had in arrays. So we cannot do that. So linked list doesn't have objects. So say if someone says search or find, say 1, okay, or something like that. So we cannot say just say find or access, say fourth object, like fourth data or something like that. We just cannot jump here. So always what we have to do is we have to start from the head of the list. The head of the list is here, right? And then we have to go through it 4 times. So access is order of n. The thing is insertion always happens at the end. So if suppose a new data comes, like suppose I want to add another integer 50, so this one will be inserted at the end. So and I can keep a pointer at the end, so insertion can be order of 1. Okay, and deletion also can be order of, so look at the deletion. So here is the, so I keep it pointer to the tail, say that is fine, but I want to delete, say value 10, right? So for that, what I have to do is I have to go from the head and then keep on checking, and then when I reach here, I delete it, and then I can create a new link between these two. Okay, so creation of link is not challenging. It can be done in constant time, but the thing is, before deletion, I have to search or look for the data. That itself takes order of n. So deletion also becomes order of n. So more or less, that's the primary idea about linked list. Let's see how a linked list is implemented in Java. Okay, so this is okay. So in Java, there's a class called linked list. Here is one example where you're creating a linked list of string objects. So this is and then we name it animals. We create an instance of the linked list. Initially, this is empty, right? So once we use this add function and add a string to that, what happens is a new node is created, right? A list node is created, and this data is assigned there. When the next data item is added, then a link is created between the previous item to the next item. A new node is created, the value is assigned, and from the previous item, a link is added to the last item, to the next item. So it goes on, and finally, when we actually try to print the linked list, you'll see all three items will show up. Okay. You see dog, cat, cow. So basically, this is how the linked list was created, developed. So initially there was nothing, there was just the head, and then after the head, dog was added, and then came cat. So new node was, the tail was here, right? So the tail was here. The new element was added. Sorry, from the tail, a link was created to the new element, and then next time, what was the last element? Animal? It was cow. Okay, so the tail was moved after cat was added. Tail was moved. This was head, and this is tail, right? So when the cow was added, a new node was created. The value of cow was assigned to it. From the tail element, a new link was created, and the tail was put here. Okay, so this is how the linked list in the example that I showed you worked. So linked list can be of different types. So different type of linked list. One is single linked list. Or single linked list. In the single linked list, the elements are actually joined by single link. Okay, so this is the head. So this is a single linked list. And then there is a double linked list. We'll write LL for linked list. So for double linked list, every element points to its next as well as to its previous. In the single linked list, only next pointer is there. Whereas the double linked list is the next pointer and previous pointer. Okay. And then there is the third one, which is circular linked list. In the circular linked list, it's like a single linked list. Only difference is the next for the last element points to the first element. So it creates a circular kind of thing. Okay, so there goes our discussion about linked lists. We'll come back with a new type of data structure in our next lecture. Thanks everyone for watching.